Okay, today we're going to talk about parallel lines proofs, and we're going to apply some of the postulates and theorems that we've learned during the last week to be able to prove lines parallel, and then also to use lines parallel and prove angles congruent or supplementary. So let's take a look at the first example. The first example says M is parallel to N, and we're going to prove that angle 1 is congruent to angle 2. So again, just like we did with our theorems proofs, we're going to put these in T-column form. Your first step is always going to be your given, which in this case, M is parallel to N. Again, as you look at this, we're trying to prove that angle 1 is congruent to angle 2. Well, we know if M is parallel to N, and 1 and 2, those are corresponding angles. We've already learned that we can state that angle 1 is congruent to angle 2 in this case, because if the lines are parallel, we know that corresponding angles are congruent. So again, just a real basic one to start off with. If lines are parallel, which they are in the given, we can show that these two are congruent because they're corresponding. Okay, let's look at example 2. Example 2 is another one where they're giving us lines parallel. So they tell us here that A is parallel to B. That's our given. They want us to prove that 3 is supplementary to 4. We look at our picture again, 3 and 4, these two angles are same side interior, which if we look at our blue resource sheet, when they're same side interior, we know that they are supplementary when the lines are parallel. Well, they're telling us the lines are parallel, so I can go ahead and say here that angle 3 is supplementary to angle 4, and that is simply if lines are parallel, same side interior angles are supplementary. So again, another two-step example. Let's look at example 3. Okay, in example 3, they're giving us two givens. They're telling us that A is parallel to B, and they're telling us that C is parallel to D. That's the given. And we're wanting to prove here that angle 1 is congruent to angle 3. Well, we look at the picture, 1 and 3, that's not one of our special angle types. So we got to draw some conclusions here. If we know that A is parallel to B, we can say that 2 is congruent to 3. It's angle 2 congruent to angle 3, because if lines are parallel, we know that alternate interior angles are congruent. If I know that C is parallel to D, I can also say 1 is congruent to 2. And angle 1 is congruent to 2 because if lines are parallel, we know that corresponding angles are congruent. Now we're trying to show that angle 1 is congruent to angle 3. Well, notice in my previous two statements, 2 and 3, 2 is congruent to 3 and 2 is congruent to 1. So notice when these are diagonal, we can state then that 1 is congruent to 3. In this case, it would be the transitive property. Now, one thing I just want to review with you, sometimes these problems, if I would have written it initially like this, 2 is congruent to 3 and 2 is congruent to 1. Notice now they're lined up. This would have been angle 1 is congruent to angle 3 by substitution. So the order and the way it's written is important for you to pay close attention to when you're writing those. Okay, let's go to example 4. Example 4, now we're proving lines parallel. So this is going to be utilizing some of your converse postulate and theorems. Again, on this one, the given is that angle 1 is congruent to angle 2. Well, I know if 1 is congruent to 2, then these two lines here have to be parallel. So I can go ahead in one step, say A is parallel to B. We know if corresponding angles are congruent, then the lines have to be parallel. So notice the way I'm writing my reason: corresponding angles congruent, lines parallel. I'm proving that lines are parallel. Okay, let's go ahead and move on to example 5. Another one where we're proving lines parallel. So here's my given. A is parallel to B, and angle 2 is congruent to angle 1. That's the given. I'm trying to prove that C is parallel to D. Well, for me to prove that C is parallel to D, I have to show that 3 and 1 are congruent. I can't just state that yet. Since A is parallel to B, though, I can state that angle 2 is congruent to angle 3, because we know if lines are parallel, again, corresponding angles are congruent. If I look at my given and my new statement that I just wrote, notice my 2's here are lined up. So I can now state that 1 is congruent to 3. That's angle 1 and angle 3, and that is by, this case, substitution. And if I know that 1 and 3 are congruent, I can now state that C is parallel to D, because if alternate interior angles are congruent, then lines are parallel. Okay, why don't you try example number 6. Given R is parallel to S and angle 1 is congruent to 2, and prove that X is parallel to Y. Go ahead and stop the video. You try it, and then once you've tried it, then go ahead and hit play and check your answer. Okay, so to take you through example 6, we've got R is parallel to S, and angle 1 is congruent to angle 2. That's the given. So because R is parallel to S, I can state that angle 2 is congruent to angle 3. And that is, if lines are parallel, alternate exterior angles are congruent. Again, I'm trying to show that 1 and 3 are congruent so that I can show that X and Y are parallel. Well, from these two statements here, I can say that angle 1 is congruent to angle 3. In this case, it would be the transitive property. And because I know 1 and 3 are congruent and they are corresponding angles, I can now say that X is parallel to Y, and that's if corresponding angles are congruent, then the lines are parallel.